So today in class we learned a little bit about the elimination method. The elimination method is used to eliminate a variable. So since we have two variables, x and y, we are going to eliminate one of them. Well, how do you eliminate a variable? Let's look at the do now that we looked at just to understand it a little bit. I'm going to go over A right now. So in A, I see, this is just simplifying, it's not an equation, but I see a 2x, I see a negative 2x, and I see a y. Well, because a 2 and a negative 2 are opposites and combine to get 0, if I add 2 x's to negative 2 x's, I get 0 x's, which means I have eliminated my x's, leaving me with just the y. Why was that important? Well, in example 1, as I'm looking at the two equations, which, may I say, are in standard form, as I'm looking at the two equations, I'm noticing that my y's have opposite coefficients. One is a positive 1y, and one is a negative 1y. So, if I add these two equations together, let's see what happens. Since I'm adding and they're lined up with their like terms, I'm going to add vertically. X plus 2x is 3x's. Y plus negative y cancels, so we don't have any y's left. And bring down the equal sign. 7 plus 2 is 9. So by adding when they had opposite coefficients, I've eliminated y's. Now I can solve for x. I'm going to divide both sides by 3 to get the x by itself, and we're left with x equals 3. Now that I got my x, I'm going to use that value of 3 to find my y. I'm going to use the first equation, x plus y equals 7. So I just found that x was 3. So I'm going to substitute in x for 3, or 3 for x. 3 plus y equals 7. Well, I don't want 3 on the same side as y, so I'm going to eliminate the 3 by taking away 3. Or adding a negative 3. Those eliminate, and what I do to one side, I do to the other side. So I'm left with y is equal to 4. So my solution is going to be set up x comma y. So my x value was 3, my y value was 4. But don't just take my word for it. Let's double check by using the second equation now. So the second equation was 2x minus y equals 2. In order for this to be a solution to the system of equations, it has to work for both equations. So I'm going to replace my x with a 3, and I'm going to replace my y with a 4, and simplify. 2 times 3 is 6. 6 minus 4 is in fact 2. 2 equals 2, and we've checked it. So our solution to this system of equations is 3, 2. Let's look at another type. Now in this type, as I'm looking at my x's and I'm looking at my y's, there's none that clearly cancel. So I'm going to have to manipulate either the top, the bottom equation, or both equations in order to get a coefficient that will eliminate. Since I see that x at the very top equation, I think to myself, what would I have to make that in order for that to eliminate the 2x below it? And the answer is it has to be a negative 2x. But I can't just change that and not change the y and not change the 7. So if I'm going to make that x a negative 2x, the way I do that is by multiplying the entire equation by -2. So this is what I get. -2 is being distributed to the x, which gets me a -2x. -2 is getting distributed to the 3y, which gets me a -6y. And -2 is being distributed to the 7, which gets me a -14. So now I'm going to rewrite the second equation. I don't have to change it at all. I'm going to rewrite it right underneath it. And I'm back to square one, like in this example over here, when I solved for x or y and then used the variable to get the answer. So back here, they're lined up. I'm going to add vertically. -2x plus 2x cancels. We're left with 0 x's. -6y plus 2y gets us a -4y. And -14 plus 6 gets us a -8. To solve for y, we divide by the number that's attached to it through multiplication. So we'll divide both sides by -4. The -4's cancel out because -4 divided by -4 is a +1, and we're left with y. -8 divided by -4 is a +2. So our answer is y equals 2. But we're not done. That's not the answer to the entire system. It's just part of the answer. Now I'm going to use one of the equations to help get the x. So x plus 3y is equivalent to 7. I don't know what x is, so I'm going to replace it with itself, an x. But I do know the value of y, it's 2, so it's going to be 3 times 2. Well, 3 times 2 is 6. So I rewrite this, x plus 6 equals 7. And to get the x by itself, I'm going to subtract 6 from both sides, making x equal to 1. So again, since the solution is x comma y, my solution here is 1 comma 2. Don't accidentally switch them. That's not good. So now I'm going to check it in my second equation. 2x plus 2y equals 6. Well, 2 times 1 plus 2 times 2. Let's see if it equals 6. 2 plus 4 equals 6. Sure does. 6 equals 6. Very good. So sometimes you might have to manipulate one, like we just did here. Maybe sometimes you have to manipulate both of them. But maybe sometimes you don't have to manipulate them at all. It really depends how it's given to you. And also, based on how they give you a system of equations, elimination might not be the best choice. For instance, I'm not going to do this, but if I go here and I look at A, it's not in standard form for both of them. Now, I can manipulate the top to get it into standard form, but I have a variable by itself, so I'll probably use substitution there. For letter B, I would most definitely use the elimination method, but I gotta be careful because the 8 and the 5, you can't easily manipulate the x's. The 2 and the -2 and the -4, the y's, yeah, I think the easier thing to do here would be to manipulate the y's. And so as I'm looking at this, I strategically pick what number I'm going to use. Now, if I'm looking at -4y, I want the term above it to be a +4y. So what can I multiply by a -2 to get a +4? The answer is a -2. If I distribute a -2 into the parentheses to the entire equation, I get -16x plus 4y equals +16. Then I can write the other one, the other equation below it, and I can eliminate